All right, guys, welcome to lesson 11.3. We're going to be solving basic trig equations again like last time, but this time the angles that we're going to be finding are not the angles that are on our unit circle that we're used to. We're used to things like 45 degrees, 30 degrees, 60 degrees, those numbers that are right on the unit circle, but we don't have angles on there like 70 degrees or something. And so those are the kinds of equations we're going to look at, and we're going to look at it in 4 parts today. We're going to look at equations with cosine and secant first. Then we'll look at equations with sine and cosine, but with positive outcomes. And then we'll look at how to deal with sine and cosecant when they have negative outcomes, because something a little different happens there. And then finally, we'll look at equations that have tangent and cotangent. So all that being said, let's go ahead and jump in and get started here. So we're going to start by looking at cosine and secant. And as you guys know, cosine gives us the x value. So I want to look at the x values for a minute. So consider this x value right here, radical 3 over 2. Where else is there a radical 3 over 2 in the place of where there's an x? Well, that would be right here. Let's see if we can find another situation like that. Here's radical 2 over 2. Do you guys see where the other radical 2 over 2 is? It's right here. And how about half? It's right here. So that process continues. Like, for instance, we could look at this x value, negative half. It has a matching one down there. Negative radical 2 over 2 has a matching one here. And then finally, negative radical 3 over 2 has a match here. And so what we've got is we've got some symmetry going on vertically. That one matches that one, that one matches that one, that one matches that one, and so on. So we have some symmetry going on, and there's even some symmetry here, like this one matches this one. Okay? So we're going to be solving some problems today, and we're going to be using our calculator. Our calculator is only going to be giving us this top half up here, so it's only going to give us one of the answers, and our job is going to be to take this answer and see if we can figure out what the other one is directly below it. So let's go ahead and take a look at our steps here real quick. So like I said, we're going to start by looking at cosine and secant, okay, because they're pretty similar. The only difference is in the first thing I want to point out is if you do have a secant, the very first thing that we're going to do is we're going to change it into a cosine by taking the reciprocal on both sides. After that, we've got a cosine and we're good to go. So once you've got a cosine, we're going to use our calculator with the arc cosine function there to find one answer. But like I said, the calculator is only going to give us the answer from the top half of the unit circle. So it's only going to be giving us an answer from 0 to 180 degrees. And I'll change this later, but that's supposed to say pi. After we've got that, I would say sketch the angle, because the next thing we're going to want to do is we're going to use that answer and some symmetry of the unit circle to find the other answer on the bottom half. So add this little picture here to your notes. As we've already pointed out, whenever you do arc cosecant, it's going to give us some answer up here. Okay, so let's just say we had an answer here. The other answer will be directly below it in the bottom half. There will always be 2 answers, okay? Now there is an exception to that statement. Sometimes there's only one answer, and that's if cosine equals 1 or negative 1. In those cases, you're only going to have one answer for those. Those don't have any symmetrical answers, so the answer that your calculator gives you will be the only answer that you get. But for all other ones, our calculator is going to give us an answer from the top half, and it's going to be our responsibility to use symmetry to figure out what the answer on the other answer on the bottom half would be. Okay, so let's go ahead and actually do a problem now. So you're going to want to have your calculators handy. So cosine of theta. The first thing that we're going to do in this problem is we're going to arc cosine both sides to get the theta by itself. Now yesterday, or last class I should say, when we did this, we just used our unit circle right away. We said, okay, well this is an x value, and so where is the x value equal to this number? But this number is not on our unit circle. It's not recorded on there, so we can't do that. So we're going to actually just use our calculator. So the first step is to arc cosine both sides. So I'm going to arc cosine this side, and I'm going to arc cosine this side. On the left side, these cancel out, and it leaves me with theta, and so now I have this. So that's how we're going to find the angle today, because I can't just look at my unit circle. We have to use our calculator. So get out your calculators, and let's type that in. If you don't remember how to do it, you usually have to push shift or second or something like that in order to get the cosine with a little -1 there. But I'm punching it in right now, and I get 58.197, and we're just going to round it to the nearest degree. So I'm just going to say it's 58 degrees. Okay, so that's one of my answers. Okay, so I've already done the first two steps. Let me take you back and show you our steps real quick. If it's secant, then change it to cosine. We didn't do that step because I'm not doing secant right now. But I just used my calculator and the arc cosine function to find one of my answers in the top half of the unit circle. Now, what I'm going to do is I want to sketch that angle out. I want to sketch the answer I just got. So we just figured out that theta, one of my answers, is 58 degrees. So I'm going to sketch that now. Where's 58 degrees at? Hopefully you guys know that 58 degrees is like right about, I don't know, somewhere around here-ish. Okay? Now I need to use symmetry to find the other angle. So directly below that, down here, there's going to be another answer. Okay? Well, if this angle right here is 58, then this angle right here is 58. So we need to figure out what is the angle from here all the way over to here, because that's the angle we're looking for. Where is that at on the unit circle? And at this point, I'm kind of relying on your guys' knowledge from 10.1 to be able to find that answer. We know that a full circle is 360. So this is a full circle minus 58. So it's going to be 360 minus 58, which is 302. And so my other answer will be 302 degrees. And that's the end of the problem. We found both answers just like that. Okay? Now you could check your work on this, by the way. You can plug it into cosine. Just take cosine of 58 and also take cosine of 302. Both of those should give you that as an answer. If those both work out, then that means you got the right answers. The answers are 58 degrees and 302 degrees. So let's review. What was the first thing I did? The first thing I did was I did arc cosine on both sides, and I got 58 degrees. Then I sketched my angle, and then I used symmetry to find the other angle that matches it directly below it. All right, let's go ahead and do another one here. First step on this guy, we have a little extra work on this one. Last time we didn't do step 1. On this one, we do need to do step 1. Step 1 is if you have a secant and want to change it into a cosine by taking the reciprocal on both sides. So I want to take the reciprocal on both sides of this equation here. So the reciprocal of secant is cosine. And over here we have 1 over negative 3.451. So we can just do that on our calculator real quick to simplify it. We'll do 1 divided by negative 3.451. And I end up getting negative 0.290. There's that. So now that I've changed it into a cosine function, the rest of it is going to be like what we did on the last problem. So what would be the next step here? Think about it for a minute. What would I do first? The first thing we would do is we would do arc cosine on both sides. So if I take arc cosine on this side, it cancels out the cosine and leaves me with theta. And on this side, I'll just write it out. But we're going to need to do this on our calculator. Okay, so let's go ahead and do that. What is arc cosine of that result? If you want to give it a try, you can pause the video, go ahead, but I'm going to go ahead and put my answer up right now. I'm getting 106 degrees, and since we're rounding to a full degree, I'm just going to put 107 degrees. I'm rounding up to the nearest degree. I don't want any decimals. I'm just going to stick with, when I get to the angle part, I'm going to make it a whole number. Okay? So there's one of my answers, but that's only one of them. So what's the next step? What is the next step? The next step is to sketch that angle. So I know that one of my answers is 107 degrees. So what does a 107 degree angle look like? Well, this is 90, so 107 would probably be like right about here. Okay, so that is a 107 degree angle. Now this next part is tricky. We need to find where's the other point located, first of all. See if you could find where the dot goes. Where would I put a dot? The other answer that is symmetrical to this one. Remember, the calculator gives me an answer from the top half, but I need to find another answer from the bottom half, and it's symmetrical to the top. Well, if I take this point here and I just go straight down, right there is where the other answer will be. I'm going to get rid of all these extra lines here real quick just for the sake of neatness, but it will be right about here, directly below that. All right, now I want you guys to see if you can figure out what that angle is. In other words, I'm going from here all the way over to here. What is that angle? Take a minute and see if you guys can figure that out. And I think it's important that you guys take a minute to figure this out, because for these types of problems, every question will be slightly different. And so you really just kind of have to wrestle with it and use what we've already learned to figure those things out based on stuff that you know already. Just watching me do it won't be helpful. So see if you can figure out that green one. If you haven't already done it, I'm about ready to start solving it now. Okay? So let me show you guys how I would solve it. I'm going to get rid of that green line for a second. If the angle in red there is 107, then this angle right here would have to be 71. Now, why is that? Because I know that from here to here is 180 degrees. So if this much of it is 107, then what would I have to add to that to get 180? It would have to be 71. So there's 71. Okay? Now, if that's 71 degrees, then because of the symmetry, this also will be 71 degrees. Wrong pen just a second. There we go. This also will be 71 degrees. And therefore, the angle that goes from here all the way around will be 107 plus 71 plus 71. Oops. Which is 249 degrees. And there's our two answers. And once again, if you want to check your work, just plug both of these into a cosine function, and you should get negative 3.451 as an outcome. Okay? All right, so actually I misspoke. You wouldn't plug this into cosine. You would plug it into secant, right? And so you would plug in, if you wanted to check your answer, you don't have to do this step. You would do secant, though. And if you want to convert that so that you can actually use your calculator, you would do it like this. But either way, you're going to get, you should end up with negative 3.451. All right? So there is how you can find theta for angles that are not on our unit circle for secant and cosine. All right, so here's a student practice. Why don't you guys go ahead and pause the video here and see if you guys can find the answers to these two problems. When you unpause it, you will see the solutions. All right, guys, so there you go. So on your calculators, you should have gotten 97 for the first one and 81, and that's if we round to the nearest degree. And then the symmetrical answers for each one of those is there. So these two are the answers to number 1, and these two are the answers to number 2. All right, let's go ahead and move along here. A note about radians and degrees. Now you'll notice that we have only been doing degrees today, and that's all I am going to do today. But I will say that you are able to get answers in radians in one of two ways. One way is to convert it. So you could just take your answers that are in degrees, multiply it by pi over 180, which we learned back in Unit 10, and that will change it into radians. Or when we get to the calculator step, you could just change your calculator setting to radians and follow the same steps. Now, I'm not going to ask you guys to do that, but I'm just giving you guys some extra information there. So you can find the radians, but we're just going to be doing degrees today. All right, so we've talked about the first set of equations. We said that we're going to do 4 things today, and that was the first one. We said we're going to talk about equations with cosine and secant first. Next, we're going to talk about equations with sine and cosecant, but only dealing with positives, because when negatives come into the picture with sine and cosecant, some other things have to be considered. So let's go ahead and take a look at some equations that involve sine and cosine. Now, as you guys know, sine has to do with the y value, right? You don't need to write this, but sine gives us the y value. So let's take a look at our y values and see what the symmetry looks like for these. On this one, I've got a half. Do you guys see where the other y value of 1/2 is located? It's not underneath of it like it was for cosine, but instead it's actually directly across from it. Oops, I didn't want to do that. I'll change my pen there. It's right to left. It's not top to bottom anymore, it's right to left. Same thing applies for any other angle too, like suppose we want to do this one. That one has a match directly across from it. Did it again. All right. And so on and so forth. So I'll do one more there, but of course it applies across the board. So this one has a match right here. Okay. So all the matches are directly across. So instead of going from top to bottom like cosine and secant do, these ones have matches from right to left. Okay? So let's go ahead and look at some steps then on how to deal with that. All right, so if there is a cosecant, we're going to change it into a sine by doing the reciprocal. Okay? Just like we did with cosine. When I had secant, I changed it to cosine. Well, when we're dealing with sine and cosecant, if it's a cosecant, we're going to change it into a sine. All right, next, we're going to use our calculator. But once again, when I use my calculator, you guys should probably draw this with me. When I use my calculator, it's only going to give me answers from the right half of the graph. It can't give you more than one answer, and so it's going to give you an answer from the right half of the graph. So after you get your one answer, let's say it was like right here, for instance. We want to sketch that angle, which I've already done. And then we're going to use symmetry to find the other angle in the left half. So we're going to go directly across. This was our first answer. That's the calculator answer. Over here is the other answer, or the symmetrical answer. So we go from right to left when it comes to sine and cosecant. So how is sine and cosecant different from cosine and secant? Well, when you're doing cosine and secant, for those problems, you go from top to bottom for your symmetry. But for sine and cosecant, you go from right to left with your symmetry. Okay? So, once again, if you have sine equals 1 or negative 1, those will only have one answer. And so you don't need to do the symmetry thing. But for all other ones, you're going to have to do some symmetry, okay, to find a second answer. All right, so here we go. A lot of the steps are pretty much the same here. So for number 1, sorry, a little technical difficulty there. For number 1, start by writing it out. Now I want to get rid of the sine so I can have theta by itself. So I'm going to do arc sine on both sides. On the left side they cancel and I'm left with theta. And now I have this. And from there it's going to be a calculator problem. So let's get out our calculator, type that in and see what we get. So I get the following: 65.9, which means 66 degrees. Once again, we're rounding to the nearest whole degree there. All right, so there's one of my answers. There's one of my answers. All right, so what do we do after we find one of our answers? We sketch it. So where's 66 degrees located? 66 degrees would probably be somewhere like right about here-ish. All right, so let's find where the other point will be located. Where will the other point be located? Now remember, for sine and cosecant, the matching answer will be on the left side. So if you go directly across this way, we should have another answer right over there. Okay, so I'm going to go ahead and put my dot there and a line here. And once again, my goal is to figure out what is this angle here. And once again, I think you guys should pause the video here and give this a try. See if you can figure out what that angle is for that purple line. Okay, so pause the video, give it a try, because once again, every problem is different in these circumstances, so it's important that you do it and don't just watch me do it. But anyway, when you unpause it, I will show you how I do it. All right, so here's how I would do it. We know that from here to here is 90 degrees, right? Well, this piece plus this piece gives me 90 then. So 60, if I take 66 away from 90, I get 24, and that's what this little missing piece right here would have to be, 24 degrees. And since these pieces are symmetrical, that means this also has to be 24 degrees. And so now I'm ready to calculate this. This green arc here, this angle that goes to the purple line, is going to be 66 plus 24 plus 24. And I get 114 degrees for that. So there's our other answer, 114 degrees. Technical difficulties again. Sorry, just a minute. There we go. And there's our two answers. All right, let's go ahead and do number 2. So number 2 is cosecant. So what should my first step be? It should be to take the reciprocal on both sides. So the reciprocal of cosecant is sine. And to find this reciprocal here, I'm just going to do 1 divided by that number and put my result right there. So let me find my handy dandy calculator here. All right, so there's that. Next, we're going to do arc sine on both sides to get rid of the sine by the theta. And let's see what we get as a result. I'm getting 13 degrees if we round to the nearest degree. So there's my first answer. So what do we do after we find our first answer? We sketch it. So let's go ahead and sketch it. 13 degrees would be a really low angle here, close to the x-axis, so something like that. All right, and so here's my 13-degree arc there. I'll try to squish it in there. 13 degrees. All right. Now, where would the point that is symmetrical to that be for sine? Remember, sine is symmetrical going to the left, so we would have a point over here that matches that. Okay, and so now what I'd like you guys to do is see if you guys can find this angle. Once again, I would encourage you to do it. Don't just watch me do it. See if you guys can find out that angle there. When you unpause the video, I will show you how I do it. All right, I'm going to go with a similar method as last time. This is 90 degrees. So 90 degrees minus 13 degrees will tell me what this piece is up here. So I get 77 degrees. Now, if that's 77 degrees, because of symmetry, this half is also 77 degrees. And therefore, the purple arc there is 13 plus 77 plus 77. And I'm getting 167 as my second answer. And there's that. All right. So now we've learned how to do sine and cosecant. So let's let you guys practice that. I'm going to pause the video here. And when you unpause it, I will have the solutions worked out for you. All right, guys. And so there's our answers. Just go ahead and check your work there. See if you agree. But that'll be it for that.